Hello and welcome to the fourth episode of AI Mastery series. In this video, we're going to reorganize our scripts to make them easier to maintain and manage. I also have an announcement to make. The project files for each episode are going to be available in an itch.io page along with builds for each episode, so you can review the code and inspect the Unity project on your end, but also you can run the build in Windows and experience what we're making from the point of view of the player. This is the result so far. So this looks like a small city with groups of guards patrolling around and civilians in blue. The civilians are the NPCs that we created in the first tutorial. There are a lot of game AI behaviors that we can implement. Each behavior is pretty easy to understand and make. So the NPC will ask themselves these questions. Should I wander? Should I follow the group? Should I engage the enemy? Is my gun empty? Do I even have a gun? And a lot more of these questions. The challenge is actually not in making these small behaviors because they're rather easy and simple to make. The challenge is how do we organize them, and for the NPC, how do they choose what to do? There are a lot of techniques that actually try to answer this question and try to organize how the NPC thinks. We can just keep writing scripts like we've been doing so far. We can implement a finite state machine or FSM. We can create a behavior tree, or we can use GOAP, which is goal-oriented action planning, or we can use utility theory. So the way I like to learn is by actually doing things. We're going to think of ways to better organize our scripts. And by doing so, we're going to think of ways to better organize our AI behaviors. And we'll orbit towards one of these techniques. Actually, we're not going to use just one of these techniques. We're going to use all of them, but in a simple, smart, and gradual way. So you only use what you need, but what you use, you will understand fully. That's actually the best way to learn and to fully understand your code. Looking at AIController, I see two problems. The first one is that catch-up distance is pretty much the same like the distance we have in the group. In group, we have straggler distance. From the scene we created, straggler distance is set at 12. And catch-up distance is set at like 5.5, let's say 6. So it's about half the straggler distance. So we're going to remove this from here. And also, if you scroll down here to the update speed method, this code that we wrote that makes the NPC catch up with their leader has no business being here. It's more appropriate to have it in the NPC group member script. And for the speed, we're going to set the agent speed to NPC walk speed when the NPC is set. So we only do it once, and then other scripts can take care of changing the speed. I'm going to cut this and paste it in the NPC group member script. Let's do it in a clean way. Let's create an update speed method. And for catch-up distance, we'll set it at half straggler distance. But here we have a problem. Straggler distance is a private variable. I think it's safe to make it public. Okay, so here, let's simplify this syntax. Let's just return if we don't have a group or if we are the leader. And down here, we were setting the agent speed. Now let's use a set max speed action like we did for the destination. Let's go into our NPC script in the events. Let's define a set max speed action, which will be mostly ignored by the player controller, but the AI controller will use it to set the speed of the navmesh agent. Let's go into our AI controller script. When the NPC is set, we're going to subscribe to set max speed. And here we're going to unsubscribe from it if we're changing NPCs. Let's define this method. I'm going to delete the update speed method. Here, when we set the NPC, we're going to set the agent speed to walk speed. Also in the AI controller script, there is no need to enable and disable the navmesh agent. As we talked about in the last video, this is a bad idea. Let's delete the catch-up distance variable. We don't need it anymore. Let's add a region here to organize the Unity methods. Let's delete the onEnable and disable methods and also the onDraw gizmos. Let's make the update method virtual. So in case we inherit from AIController and we want to override the update method in the NPC group member, let's use the update speed method. We defined it, but we actually don't use it. We're going to fix that. Let's do it here in the update method. Actually, when I am the leader, I want my max speed to be set at walk speed. So I'm going down here to the update speed. Now we go back to the game and run it. So if everything works like it did before, it means that our code is working fine. To be honest with you, I don't like that NPC group member has a reference to the wandering behavior. Right now, our NPCs have this vague AIController script. For each type of NPC, we want a specific script that will manipulate the other scripts and perform the specific behavior of that NPC. I believe this is a cleaner way to organize our NPC behaviors. So let's do it. Let's go to our NPC group member script and remove the NPC wander field. Let's also remove all calls to set wander enabled. Let's also remove these if statements. I'm going to remove NPC group member from the player controller. So let's go to the player controller prefab and remove the NPC group member. The value of this script is that it sets the destination, but we can do that in the player controller script as well. So we're going to remove this. And let's look at the guard AIController. So this is fine, but actually I don't even want these scripts to be mono behaviors. What I actually want to do is do something like this. So let's say this is the update method of the guard script. Let's say we have a follow group variable and a wander variable. In the update method, we want to call follow group.update and we want it to return a value. The update method of follow group will return a task status. So here we've defined an enum NPC task status with 3 values: success, failure, and run-in. So update will return one of these values. If it has finished, it will return either success or failure. If it hasn't finished, it will return the run-in value. So here we're going to check if follow group.update is not equal to NPC task status run-in, then we're going to update the wander state. So all of this is in the guard AIController script. So we want both follow group and wander to be NPC tasks, and the NPC task class will have an update method that returns NPC task status. With this way of doing things, we can expand the behavior much easier. So for example, we can also have an engage enemy task that will also inherit from NPC task. And here, if we have an enemy and we call the update method on engage enemy, and if engage enemy is still running, we'll simply return. If we don't have an enemy or if the engage enemy task has finished, we'll be able to execute the rest of the update method. So we're going to either follow group or wander. Here we can also expand on this. If the guard hears a strange sound, then we're going to investigate the area where that sound is. So we're going to add an investigate area task. So here basically what we've created is called a behavior tree. If you're familiar with the behavior tree, then here we've created a selector. If you're not familiar with behavior tree, it's fine. So the code is self-explanatory. So here all these tasks are sorted from high priority to lower priority. The engage enemy task has the highest priority. So if we have an enemy and we're still engaging, will immediately return. If we don't have an enemy but we hear a strange sound, then we're going to investigate the area. As long as we're still investigating the area, we'll return. And if all of these fail, we're going to simply fall back into our follow group behavior. If that also fails, we're going to fall back to our wander behavior. This way of doing things will allow us to organize our NPC code much easier and is very simple to understand. You can easily read this code and understand what it does. Now, if we want to convert our NPC group member and NPC wander scripts to NPC tasks for the group member, it will be easy. By the way, we're going to rename it to follow group, which is more expressive. So if we want to transform this script into an NPC task, it will be easy because it doesn't have any parameter. However, for NPC wander, we'll have to add all these parameters to a class. Let's call it wander parameters, and we'll have that class as a serialized variable in guard AIController, so we can edit the parameters in the inspector. Let's go back to our pseudocode. So here we can simplify the update method even more. So here what we're basically doing is we're selecting the task with the highest priority. If one of these tasks has the highest priority, that's what we're going to select, and we're going to call update on it. So we're going to go into our NPC task and we're going to define a method that returns a float variable. Let's call it getUtility. If the NPC behavior has a list of tasks, it will simply ask each task, okay, what's the utility of this? What's the utility of that? And it will pick the one with the highest utility. So for example, here in the update method, if we don't have an enemy, then the utility of engage enemy will be 0. If we heard a strange sound or we have any reason to investigate an area, then let's say investigate area will have a utility of 2. And for the wander and follow group behaviors, maybe wander can have a utility of 1 and follow group can have a utility of 2. So in this case, let's make investigate area have a utility of 3. So if we don't have an area to investigate, then the utility of investigate area will drop to 0. Using this value, we can simplify the update method even more. So here, instead of doing all of this, we can call a method getTask with highest utility that will select from all the tasks that we have. It will select the one with the highest utility. And then we can call update on this task. This is also useful if you want to draw gizmos. So for example, if we want to add a draw gizmos method here. So this is not a Unity callback, since NPC task is not a mono behavior. However, our guard AIController will be a mono behavior. Here in the onDrawGizmos method, we can do the same thing. We can pick the task with the highest priority, and instead of update, we'll call drawGizmos. So this is a much simpler and better way to organize our tasks, much better than this. Let's actually write the code that will do this. Let's go to our scripts folder. In NPC, we'll create a task system folder. Let's add an NPC task class. This will not inherit from mono behavior, so we'll remove this. Let's also define an NPC task status enum. So if we use getUtility, we actually don't need an NPC task status anymore. However, we're going to add it anyway because that will be useful later. And you will see some scenarios where we need that. For example, if we want to implement a sequence of tasks, we'll need to wait for each task to finish before going on to the next one. So when we do that, we're certainly going to need an NPC task status returned in the update method. Let's write an update method that returns an NPC task status. Let's also write a drawGizmos selected method and a drawGizmos method. Let's make NPC task abstract. Let's make the class abstract so we don't have the option of instantiating it. And let's add an NPC member and define a constructor that takes an NPC as parameter. So when we create an instance of this class, we have to define the NPC variable. So in the update method, let's return a value. So let's return a success value by default. And finally, let's define a getUtility method that will return 0 by default. Here I created another folder for our tasks. So we'll differentiate between the task system, which has the NPC task method, and the various tasks that we're going to be implementing. Let's start with the follow group task. Here we're going to copy the code in NPC group member. We need to change the signature of the update method to public override NPC task status, and we'll return a task status of running in the end. Let's override the getUtility method. We'll return 1 by default. Actually, let's return 2 by default. Actually, before continuing any further, I want to simplify the syntax of some check-in we do on the groups. So I'm going to switch to the NPC script and add some convenient methods. We define 4 methods: hasGroup, isGroupLeader, isGroupFollower, and group has stragglers. Let's go back to our follow group script. Let's define the utility of the follow group task. So if you don't have a group, the utility will be 0. If we are the group leader and the group doesn't have stragglers, we'll return 0. Otherwise, we'll return a value of 2. We also need to define a constructor for the child class that takes an NPC as parameter. Let's go back to the guard AI controller script. Here I'm going to remove the reference to the NPC group member. Let's define a follow group variable, and we're going to override the setNPC method. If NPC is not null, we're going to instantiate a new follow group with the NPC as parameter. Here, if we have a group, we simply call the update method of follow group. In the else block, we don't need to do anything actually. Now we're going to run the game and hopefully our code will work. Okay, so we're running the game and the code seems to be working just fine. So we did it. We no longer need the NPC group member script. In the guard AI controller, let's define a list of tasks. Then in the setNPC method, we're going to clear the list. Then we're going to add the follow group variable to it. And also down here, we'll be adding the other tasks as soon as we create them. Let's define a method called selectTaskByUtility that will return an NPC task. But actually, let's do something clever. Let's actually define it in the NPC task class as a static method, which takes a list of tasks as parameter and returns an NPC task. We start by checking if tasks is null or is empty. In this case, we return null. Then we're going to pick the best task. For this, we use a highest utility float and we set it to float.meanValue. Then we loop through the list of tasks. If we find a task that has a utility higher than highest utility, then that task will be the best task. And at the end of the loop, we return the best task that we found. Back to our guard AI controller, we'll pick the task with the highest utility, then we'll call update on this task. We can go ahead and comment this code. Okay, let's rewrite the wander behavior as an NPC task. Let's create a wander class inside our tasks folder and make it inherit from NPC task. Let's also add the system.serializable attribute to it, so we can edit it in the inspector. So I'm going to copy these values and make them public. Let's define the constructor of the wander class. It will take the NPC as parameter as well as the wander parameters. Let's override the getUtility method. The Wonder task will always have a utility of 1. Let's override the update method. We'll make it return the running state. Now all we have to do is copy the code from NPC Wonder back to our Wonder script. Currently, we have no way of doing the same thing that we did before in the onEnable method. So we need to know when we've entered a task and when we've exited that task. So in the Guard AI controller, we're currently managing the list of tasks, but actually what I'm thinking of doing, we can have the list of tasks in the AI controller and we can manage it there. When we derive from AI controller, we'll have all the task management methods available to us. Okay, so let's do it step by step. Let's implement all the functionality in the Guard AI controller. Once everything works, then we'll move the code to our AI controller. Here I'm adding a setCurrentTask method, and I'm defining a current task as a class attribute. In the setCurrentTask method, we'll check if current task is different from the task we give it as parameter. If the old task is not null, we'll call onExit on it. Then we'll set current task to task. And if current task is not null, we'll call onEntry. In the update method, we'll call pickCurrentTask. PickCurrentTask will select task by utility, then set the current task to that task. If current task is not null, we're going to call the update method on it. Let's define the onEntry and onExit methods. Going back to the NPC task script, let's add the methods over here. Actually, for more consistency in naming the methods, we're going to rename update to onUpdate. This will also differentiate it from the update method of mono behaviors. Let's also change drawGizmo to onDrawGizmo. Same thing for drawGizmo selected. Okay, let's go back to the Wonder script. We're going to copy the code from NPC Wonder. We're not going to copy the parameters, only the variables that we use in the behavior. Let's override the onDrawGizmo selected method. So instead of transform position, we're going to use npc.position. And instead of search radius, we're going to use parameters.searchRadius. We're going to copy the code in the onEnable method to the onEntry method, and the code in the update method to the onUpdate method. Of course, Visual Studio is underlining my methods in red. That's because I need to define them as well. Now let's replace these variables by the variables in the parameters object. Okay, that's it. Hopefully this will work. Let's go back to our Guard AI controller script. We don't need the reference to NPC Wonder anymore. Instead of it, we'll add Wonder parameters and the Wonder task. Here in the setNPC method, we're going to create the Wonder task and add it to the list of tasks. Let's go back to the editor. Here I'm going to go into our Guard AI controller prefab. So here I have my Wonder parameters. I'm going to copy the values in our NPC Wonder script. So for the search radius, let's set it to 30. Let's set the max Wonder time to 10. Max Wonder time to 50, and max wait time to 1, then max wait time random to 3. Now we can remove these two scripts. We don't need them anymore. Now let's run the game. Okay, everything seems to be working as expected. Back to our Guard AI controller, we're going to move the list of tasks with the current task to the AI controller script, along with the relevant methods. Since these variables will be in the AI controller script, we need them to be protected. Let's cut this and go to the AI controller script, go to definition. Then I'm going to have them over here. And I'm going to make this a protected method. Protected. And also the pickCurrentTask method. Yeah, actually the update method will be the same. We don't need to override it here. So I'm going to move this code back to the update method of the base class. Okay, let's go back. So here I don't need to override the update method. Let's move these methods to the AIController class. Let's create a region here. Let's call it task management methods. The question is, do we need the child classes to access these methods? I don't think so. So we are going to remove the protected keyword here. So all we have in the guard AIController is the setNPC method override. However, we can make this much cleaner. In the setNPC method of AIController, we can actually call a method that we can override. Let's call a create tasks method that we're going to define here. Before calling this method, let's clean up the list of tasks. So here, instead of overriding the setNPC method, we're going to actually just override the create tasks method. Here we simply instantiate wander and follow group and add them to the list of tasks. And we don't need all of this stuff. So this is much cleaner than the way we did it before. So actually this script can also be used for the civilians if you think about it. So if we don't have a group, the follow group utility will be at 0 and the NPC will execute the wander task. So we might as well add the same thing for the civilian. So let's go back and refactor our civilian NPC prefab. Let's actually just give it a guard AIController prefab as a child object. The civilians are wandering around. Yes, we can confirm that the same script works also for civilians. Actually, our AIController works as a selector, and more specifically, a utility selector. What if we want to use this utility selector somewhere else? Let's separate the functionality even further into its own class called utility selector. Here in our task system folder, let's create a new class called utility selector. The utility selector will inherit from NPC task. So actually, let's rename it to NPC utility selector just to keep the names consistent. Let's move the list of tasks and the current task to our new script. In AIController, we'll use a utility selector. Let's create our utility selector here. In the update method, we'll just update our utility selector. Let's move set current task and pick current task to the utility selector. Let's override the onUpdate method. This is actually a public method. Okay, so what value should we return here? So the utility selector will select the task with the highest utility, and then normally it should return current task.onUpdate. Otherwise, let's return a success status. Then let's go back to our guard AIController. Here in the create tasks method, we'll use a create tasks method. The create tasks method will take a variable number of parameters. We'll give it wander and follow group. Okay, so we don't need to add tasks here. Let's go back to utility selector and create the create tasks method. I noticed a mistake that I made earlier. So here in set current task, we shouldn't be calling onExit on the new task. We should be actually doing it on the old task. Here, if current task is not null, we should be calling onExit on it. Then we set current task to the new task. Then if the new task is not null, we call its onEntry method. Let's do another refactoring pass. I don't like the fact that the utility selector inherits from NPC task. So here we don't use the NPC variable. We have no need for it. Let's actually define a simple task. Let's create a new namespace. Let's call it task system. Let's rename NPC task status to task status, and let's move it to the task class. Here NPC task will inherit from task and will also be in the task system namespace. Let's move all this code to the task base class. In the select task by utility, let's use task instead of NPC task. Now in our utility selector, we're going to rename the class to simply Utility Selector. It will inherit from task. Let's replace all the occurrences of NPC task with task. Don't forget to add the utility selector to the game.taskSystem. We still need to replace NPC task with task down here. Okay, so NPC task will be a special type of task that has a reference to an NPC. Otherwise, let's keep the task system as generic as possible because not all tasks will need access to an NPC. In wander and follow group, let's use the task system. Both of these classes will be inheriting from NPC task, and that's understandable because they need access to an NPC. However, if we add something like a wait task, it doesn't need an access to an NPC. So what the wait task will do, after it enters, it will set a timer and will only succeed when the timer has elapsed. So let's define a private property timer. Let's define two public variables, duration and duration random. Let's override the onEntry method. Let's override the onUpdate method. We're going to subtract time.deltaTime from the timer variable. If timer reaches 0, we're going to return a success status. Otherwise, we'll return the running status. Let's create a convenient constructor that takes duration and duration random as parameters. That way we can quickly create a new wait task. Then let's add a sequence task that will execute the tasks one after the other. The sequence and our utility selector are both composite tasks, so perhaps we can create a new base class for these two classes. Let's call it composite task. Let's move some of the code to the composite task, so the composite task will also have a list of tasks. However, we will not be moving current task here. Maybe some other composite tasks will run many tasks at the same time, so the notion of current task will not make sense for them. So we'll just duplicate current task in the sequence as well. So this onUpdate method is specific to the utility selector. Same thing for setCurrentTask and pickCurrentTask. So let's inherit from composite task here. And let's make this abstract. Okay, now let's go to our sequence. We're going to be using the task system namespace and we'll be inheriting from composite task. Here we'll also be using a current task variable. However, we'll be setting it to the first task in the onEntry method. You know what? Instead of using current task, let's use a current task index. In the onEntry method, we'll be simply setting the current task index to 0. In the onUpdate method, if the list of tasks is empty, we'll return failure. We'll execute onUpdate on the current task. If it returns a success, then we increase the current task index. If we are at the end of the tasks, then we return a success. So the sequence succeeds when all child tasks have succeeded. And if the current task fails, then the whole sequence will fail. Otherwise, we return a running status. Here in our Guard AI controller, we need to use the task system. Same thing in our AI controller. Let's use the task system here. Let's create another task called log. it will simply call debug.log on our text and return a success status. We're going to add another task called a repeater. So the repeater will have a child task. Every time the child task ends, it will start it again and will repeat it forever. Here in the onUpdate method, we're going to call the onUpdate method on the child task. If the status is a success or failure, we're going to call onExit, then onEntry on the child task, and we're going to always return the running status. So this repeater will repeat forever. We also have to override the onEntry method and actually call the onEntry method of the child task. Okay, now we've defined a lot of tasks. We need to test them in a new mono behavior. Let's create a mono behavior called task system test1. Here we define a root task. This root task will be a repeater. Let's first define a sequence. We're going to have a sequence where we print something on the console, then wait for like 1 second, and then repeat it over and over again. So let's create a log task, and let's create a wait task. We're going to call create tasks on the sequence with log and wait as arguments. Once we do this, we're going to call onEntry on the root. Then in the update method of the mono behavior, we're going to call onUpdate on the root. Here, before moving on, let's review the sequence script. So here we have a problem. We don't call the onEntry and onExit methods of the current task. That's what we'll do now. If we do have some tasks, we'll call the onEntry method on current task. Then when we increase the index of the task, before we increase the current task index, we save the previous task. Then before returning the success status, we call onExit on the current task. And if we haven't reached the end yet, we call onExit on the previous task, then onEntry on the new task. Then before returning the failure status, we make sure to call onExit on the current task. Here we have an error on the console, so I'm going to double click on it. In the AI controller, let's make sure to use the task system. Okay, so here the constructor doesn't need the NPC argument. This should fix the problem. Now let's create an empty object. Let's call it task system test. Let's add our script to it, then run the game. Ooh, here we have it printed hello world. Then we have a whole bunch of errors. Okay, so we have this error message, current task index 2, out of bounds, task count equals 2. This occurs in the onUpdate method here. So here, I made the mistake. I actually have to call onExit on the previous task, not the current task, because of course the current task will be null at this stage. Now hopefully it should work. Okay, so it works. So as you can see in the console, every second we print hello world. Let's go back to our code. Now that our sequence is working, let's actually override these methods. So we need to override the onDraw gizmos and the getUtility method on our newly created tasks. Let's add some structure to this folder first. I've created some subfolders to organize our task system. First, we have the actions. These are the tasks that do one thing and return. So our actions do not have any child tasks. They just do something. Then we have our base tasks. Then we have our composite tasks. And finally, our decorators. So a decorator is a task that has exactly one child task. So far, we have one decorator, which is the repeater. But we can add more later. Okay, let's go to our composite tasks. Let's start with the sequence. First, let's write a method. or is current task index valid. Let's override the onDrawGizmos methods in the onDrawGizmos and onDrawGizmos If the current task index is valid, we're going to call the method by the same name on current task. Now let's override the getUtility method. So there are a lot of ways to implement this method. You can add the utility of each task. You can compute an average number. Let's just return the maximum utility across all of our tasks. We set a max utility variable to 0. Then we go through the list of tasks. We get the utility of each task. If utility is superior to max utility, then we set max utility to the utility of that task. Then when we exit the for each loop, we return the max utility that we found. Let's also override these methods in the utility selector. Here we're going to check if current task is not null, then call onDrawGizmos. And to get the utility, we'll simply return the utility of the current task, since the utility selector already selects the task with the maximum utility. Otherwise, we return 0. Now let's go back to our AI controller script. Here we need to call onDrawGizmos on the utility selector. Let's go to the Unity method region. Here the utility selector may be null. So instead of instantiating the utility selector here, I'm going to remove this line and instead instantiate it in the constructor of the monoBehavior. In fact, we never need to instantiate this. When we call create tasks, we'll simply call create tasks on the utility selector, and the list of tasks will change. No need to change the utility selector itself. Let's run the game and let's select a guard leader. We should be able to see the wandering gizmos on it, the cyan wire sphere and the cyan sphere that draws here. So these are the wandering gizmos that we had before. Yeah, so everything works like it did before, except now we have a behavior tree that uses utility theory. Our wander behavior is using a finite state machine. So as I said before, we're going to be using all the techniques to implement our NPCs. So thank you for watching. In the next video, we're going to play with our task system some more to create more behaviors. See you then. Bye.